Hello everyone, welcome back to my channel, that is at CURIOCHEMISTry. So today's class is the class 1, which is particularly based on organic reactions. That is our common topic, which is having a major topic in the CSIR Net exam, okay, which is in the December. So we are going to understand about the basic of organic reactions, how reactions are happen. So the objectives of this video are, you can see here, these are the objectives. First one, why molecules generally don't react with each other, right? If suppose if you keep salt plus water, okay, without mixing, are they give any solution to us? No, right? Then why sometimes molecules do react with each other? Yes, after mixing or with any situations you made such situations, so they will react with each other, right? So now, how molecular shape and structure determine the reactivity, we are going to understand that. In chemical reactions, what moves? Electrons move from full to empty orbitals, okay? Remember this line. In chemical reactions, electrons move from full to empty orbitals. It will be, you will see this, okay? Then identifying nucleophiles and electrophiles. What is nucleophile, what is electrophile, we are going to understand at the end of this video. Then how to represent the movement of electrons in reactions by curly arrows. So we are using curly arrows to show the movement of electrons. Okay. Now most molecules are at peace with themselves, okay, if you are not touching them. For example, bottles of H2SO4, okay, NaCl, NaOH, or water, or you can take this acetone. Okay, they are unreactive, right, for years without any chemical reaction. But if you mix all this, we will get the chemical reaction, right? So this chapter is the introduction of the behavior of organic molecules, right? This chapter is introduction of behavior of organic molecules, how they behave. Okay, so we know that organic molecules react because of what? They move, right? Organic molecules, they react because they move from one place to another place in a particular solution I'm talking, right? So what exactly happened there? The collision. Do you remember the word collision? Okay, collision is happening. So this collision between two molecules lead to a chemical change, right? Collision between molecules lead to chemical change. So during this, they get some activation energy. Sometimes you will see the greater activation energy or the lower one. It depends on the molecules, right? So during this, they get some activation energy to perform chemical reaction. Okay, sometimes they need charge attraction, right? So we are going to understand one by one how the chemical reactions are happening during the chemical change. So to understand organic chemistry, you need to be fluent in two languages, okay? The first language will be the structure of atom, bonds and orbitals. You should know this before understanding the organic chemistry. Then, and the second language will be about their reactivity. Chemistry is the first and foremost about dynamic features of molecules that we know. That is, what is it? The feature, how to react new molecules from old ones, right? So for example, to understand this, we need some terminology and tools for explaining or predicting or the talking about the reactions. We need to know some tools. Okay, what are these? These are the structure and the reactivity of the organic molecules. So now we have here one example, the charge between, okay, charge attraction, okay, charge attraction brings molecule together. Okay, what is it? Chemical reaction is means what? We have to bring together two molecules, right? So first one is will be charge attraction brings molecule together when you mix. Here we have one example, I'll write here. Okay, if you mix NaCl plus AgNO3, that is silver nitrate, what you will get? You will get, first of all, we will get the cations and anions, that is Ag plus Cl minus. These ions you will get. Okay. So Ag plus will be cations and Cl minus will be anions. Fine. So the common cause of reaction between cation and anion is what? The dipole one. Dipole means what? Where you can see the two dipole. I will write here. Dipole is nothing but where you see two opposite charged particles or molecules. Okay. Or reagents. So here for you, I just took one example again. When reaction between cyanide and formaldehyde, okay, reaction between cyanide and formaldehyde, you can see here this carbon of cyanide is having negatively charged reagent, okay, and the carbon of this formaldehyde carboxyl group, okay, which shows the positive, means you can see here two opposite signs, okay, opposite charge, right? So because of this opposite charge, they get attracted, as we know about the magnet also, right? Magnet also has plus and not plus and minus, north pole and south pole, so they get attracted, okay. Different charges or not similar, okay, not similar charges get attracted, same way plus and minus get attracted, we know that. So here they show electrostatic attraction, here they show the electrostatic attraction, okay. So what you can see here, because of the dipole and because of the charged reagent, right? But sometimes, okay, sometimes it is not necessary that only charged reagent will be required for such type of charge attraction reaction, no. So sometimes we can see some reactions are there where a lone pair of electrons are also involved, okay. So take the example number 2, okay, example number 2, that is reaction between water and formaldehyde only. So where oxygen has the lone pair of electron and same the carbon of carboxyl group shows the plus sign. So again here you can see electrostatic attraction, right? So in during the charge attraction reactions, we can see the charge reagents are involving in this such type of reactions, or the lone pair of electrons are also involving, okay. Now what if there is no charged reagents are there, okay, if there is no lone pair of electrons are there, so what? So we can see such type of reactions are there where orbital overlapping is there. So the second point will be orbital overlapping brings molecule together, okay. So we have example of ethylene and bromine, okay. So you can see here, are you able to see here any charged reagent or the lone pair? No. So here the empty orbitals are interacting, okay. So the reaction still takes place where no dipole, no lone pair, no electronic attraction is there, no activation energy is there, still they react or interact because of their what? Orbital. So here reaction between ethylene and bromine takes place without no charges, no dipoles, only with the orbital interactions. So we will get the bromine and the bromine, okay, single bond. So a bond forms when electrons move from nucleophile to electrophile. How this is happening now? Let's understand about the nucleophile and electrophile. So the nucleophile donates electrons. Understand, nucleophile which donates electrons. Okay, we can say it is donor, and electrophile which accepts the electrons. So acceptor. So nucleophile is what? Donating electrons, and electrophile is known as accepting electrons. So sometimes we write nucleophile as Nu or Nu minus because it gives the electrons, it is getting the minus charge. Okay, and electrophile E or E plus, getting the plus charge. So for this we have examples here. The first example will be H plus and Cl minus. So here electrophile will be the plus one, that is H plus, and nucleophile will be the Cl minus. So in these what we can see, electrostatic attraction is there and they form the new bond. Okay, so same how can we show by the curly arrow is showing which showing the movement of electrons. So as just we said that nucleophiles donating electrons, the arrow will be come from Cl minus only, that is from nucleophile. Okay, it will not go like this, it is wrong. This is a wrong way of showing movement of electrons. It should go from nucleophile to electrophile. So our nucleophile is a Cl minus and H plus is a electrophile. So the arrow should be go like this, and we are getting H plus here, that is a HCl we are getting, and this is a straight arrow, straight reaction arrow. Okay, now one more example is there. Same way, here we took electrostatic attraction, now we are taking the orbital overlapping situation. So we are taking here ammonia, NH3, and borane, that is BH3. Okay, so here you can see lone pair at nitrogen, that is lone pair of electrons at n, and here empty what, empty p orbit. Here already written electrophile has an empty p orbital, so the lone pair electron will be overlapped to the empty p orbital, because at the beginning I just told. Okay, here I'll show you where it is. What I said, electrons move from full to empty orbitals, right? So in this way we are getting our nucleophile, that is n, and electrophile, that is, just a minute, correct, nucleophile and electrophile n plus and Cl minus, which shows the new bond, that is new sigma bond. Okay, we will understand about the bonds, sigma bonds, pi bonds, in our next video. So how we are showing the movement of electrons, we are showing the movement of electrons from nucleophile to electrophile, that is n is nucleophile and b is electrophile. Here we are showing with the curly arrow, and we are getting the, this is the structure after orbital overlapping. Okay, so we will stop here. Yes, I just added here this definitions, and we will summarize this. So sigma bonds formed by the head to head overlap of atomic orbitals. Sigma bonds have electron density concentrated between the nuclei bonding atoms. Okay, sigma bonds are stronger than pi bonds. Remember this, sigma bonds are stronger than pi bonds. And what are the pi bonds? Pi bonds are side to side overlapping. Okay, side to side overlapping of atomic orbitals, and pi bonds have electron density concentrated above and below, and here concentrated between the nuclei, and here above and below of the plane of the nuclei of the bonding atoms. And sigma bonds are stronger than pi bonds. Okay, sigma bonds are stronger than pi bonds. Remember this. So we'll summarize this. In general, molecules repel each other, need to overcome, they need a minimum amount of activation energy to react, right? Most organic reactions involve interaction between full and empty orbitals. Many but not all involve charge interactions which help overcome electronic repulsion. Some ionic reactions, nothing but charge attraction. We don't need to analyze whether charge or orbital interaction is the most important factor in bringing molecules together, but you need to be aware that both may be involved to varying degrees. Means you cannot say only electrostatic attraction happen, or only orbital interaction happen, or orbital overlapping is happening. Okay, so might be both is there. So with this we'll stop here, and in the next class we will understand about the pi bonds and the remaining basics of the organic reactions. Thanks for watching.